The second example of electrolytic cell is down cell. This cell is used for the commercial preparation of sodium metal by electrolysis of molten sodium chloride, molten NaCl. We melt sodium chloride and we pass electricity so that sodium is produced at the cathode and chlorine gas is liberated at the anode. Technically, it consists of a rectangular steel tank. A graphite rod is introduced from below into the tank, and this graphite rod acts as an anode. It is graphite anode. Above the graphite anode is a dome with a fine hole. It is dome having a fine hole through which chlorine gas escapes, which is produced at anode. The cathode is a wire or a rod which is made up of iron or copper. Iron or copper rod surrounding the anode is act as cathode. It is iron or copper cathode. And the cathode is separated from the anode as well as from the vessel of the tank, a vessel of the cell, by steel gauzes. The outer steel gauze, it prevents contact between the cathode and the vessel, and the inner steel gauze, it prevents contact between the products which are formed during the process. It prevents contact between sodium, which is produced at cathode, and chlorine, which is produced at anode. Above to one side of the container, there is a special reservoir for the collection of sodium metal. It is the special reservoir where the sodium metal is collected and then it is tapped out. It is a special reservoir for the collection of molten sodium. So in this case, a mixture of sodium chloride and little calcium chloride is taken in the vessel. Calcium chloride lowers the melting point of sodium chloride, and the electrodes are connected to battery and electricity is passed so that the mixture is melted at 600 degrees centigrade. Electrodes are connected to battery and electricity is passed when the following reactions occur. We have sodium chloride solid in the presence of calcium chloride solid. When it is heated to 600 degrees centigrade, it melts and produces sodium positive ion in liquid state and chloride negative ions in liquid state. The chloride ions move towards anode, which is present in the middle, lose 2 electrons, convert into chlorine atoms, and these chlorine atoms then combine to produce chlorine gas. The electrons move through the battery. They move towards the cathode, where they are caught by 2 electrons are caught by sodium metal at the cathode. Sodium metals move towards cathode, chloride ions move towards anode. The sodium ions, they accept 2 electrons and they are converted into molten sodium. This sodium is collected, is in the form of vapors, and it rises to the special reservoir from where it is taken out. There are many more examples of electrolytic cells. For example, we have the Hall-Héroult cell. Third example is Hall-Héroult cell. Now this cell is used for the electrolysis of aluminium oxide or alumina, Al2O3, in the presence of little cryolite, sodium aluminium fluoride, Na3Alf6, to get aluminium. It is one of the steps for the extraction of aluminium by the Hall's process. The fourth example of electrolytic cells is the hoop cell. and this cell is used for electro refining of copper. The copper which is obtained commercially has a purity of 99.6%, and this purity is not good for making electrical windings or to be used in electrical circuits. Therefore, it is purified to 99.99% by electricity. Electricity is passed through a tank which contains solution of sulfuric acid, copper sulfate, and metal rods. Pure and impure rods are suspended alternatively in this solution. Pure, impure, and pure. The pure rods act as in cathode, and the impure rods, they are made the anode. When electricity is passed, copper from the impure rods dissolves into solution, and then it is deposited at the pure rods, from which it is scratched, because on the pure rods there is a layer of graphite on which the copper deposits, and this graphite layer in between the original electrode and the deposited copper is helpful in scratching the copper from the cathode. Now we come to second type of cells, which are known as Voltaic cells or galvanic cells. We had already discussed that Voltaic cells or galvanic cells are the devices in which a spontaneous chemical reaction takes place and it generates electrical energy. These are also known as batteries. Now there are different types of batteries, which may be the primary batteries. These batteries are irreversible batteries. When the chemicals in these batteries are consumed, they cannot be reversed again, or we can say that once they are discharged, they can't be recharged again. They can't be recharged. Example is the dry cell or Leclanche cell, which is commonly used in batteries in homes. Leclanche cells. Secondary batteries are those batteries which can be used again and again. They can be recharged again. And the most common example of secondary batteries are the lead storage batteries. The third type of batteries are known as fuel batteries or fuel cells. In these cells, fuel and oxidant react together and they produce electrical energy. One common fuel cell is oxygen-hydrogen fuel cell, in which hydrogen and oxygen gases are used to generate electrical energy by a chemical reaction in which water is formed. The fourth type of batteries are known as solar batteries. These batteries, they generate electrical energy from light. So these are the different type of voltaic cells or batteries which we commonly face. Allah Hafiz.